Hi, this is Algebra 1, Module 7, Lesson 11's practice problems. We're just going to work on a little bit of conversion to start with, just to warm up. So, when we're working with areas, it's sometimes essential to convert between units of measure. For example, changing from square yards to square feet and so forth. So we're going to convert the areas below to the desired measure. Now, keep in mind, the area is two-dimensional. So, for example, 1 square yard is actually 9 square feet because 1 yard is 3 feet and then 3 feet on each side. So that's 9 total. So if you're going down here, we know that 1 square yard equals 9 feet. Well, we want 7 of them. So 7 times 9 equals 63 feet squared. Okay. So this next one, how many squared inches are in a foot? Well, 1 foot would be a 12 by 12, which is 144 inches square inches. So if there's 5 of those, then we want to do 5 times 144 and get 720 inches squared. Okay, here, 1 mile is actually 5,280 squared. We have to do that by that. So that actually, that's a really big number. So you type that in, you get 27,878,400. So there's no other conversions on there. And that's feet squared. Okay. Here we have 100 miles. Well, 1 mile is 100 times 100. So that's 10,000 centimeters. And then if we throw 2 more zeros on there because we are timesing it by 100, so we have 10,000 times 100, then we have 1 million centimeters squared. Okay, here's 300 feet. Now we got to go backwards. Oh wait, no, we don't. Yeah, we do. We're doing. So if we have 300 feet, well, 9 of them equal 1 yard. So then we are going backwards to 300 divided by 9. And no, this one we're still multiplying by 9, which doesn't make sense. I think they wrote those backwards. I think this is one of their typos. So for this one, I think they really meant yards squared, feet squared. So this is one of their typos in here. So again, 1 yard equals 9 feet. So 9 times 300 equals 2,700 feet squared. And the same thing over here. They did a typo because we're trying to convert from the bigger to the smaller. So inches squared. So we said it was 144. Let's go backwards. 1 foot equals 144 inches squared. So 96 times 144 equals 13,824 inches squared. So these are our final answers here. All right. Lovely typos. Okay, so now let's get back into the parabolas. So transformations and problems, symmetry, and all that. So graph each of these functions. Well, this first one is just the x squared. So that's, zoom in just, me. Zoom in a little bit more on these guys so I can write these a little easier. All right, so x squared. So that's going to start with, we'll do this one in the blue. So 0, 0. 1 squared is 1. 2 squared is 4. Up here. 3 squared is 9, and that's all the more I can put up here. Okay. And so that's the first one. Then the next one, let's do in purple. X squared minus 9. So I'm basically taking all of these and going down 9 spots, right? Because 0 squared is 0 minus 9. 1 squared is 1 minus 9, which would be negative 8. 4 minus 9 is negative 5. Negative 5. And this last one, 9 minus 9 is 0. I suppose we could do 16 minus 9 is 7. We could do another one yet. It's 4 squared minus 9. Be all official there. Okay, and the last one we'll do in green. So it's a plus 2, which means my vertex is going to be at negative 2, negative 9. And so now it looks like, off. Now it looks like these are going to be, all of the purple are going to be scooted left 2. So instead of 1, 2 over is negative 1. Instead of 2, 2 over is 0. And mathematically we can do that because let's put in 0. 0 plus 2 squared is 4. 4 minus 9 is 5. If I throw in a negative 2, then that puts us back here. If I put in a negative 1, negative 1 plus 2 is 1. 1 squared is 1. Minus 9 is negative 8. So everything's just kind of scooted over 1. So here's 3. So if it scoots over 2, it's over at 1. And if the 7, let's see, 4. 4 plus 2 is 6. No, 2. We need 2. 2 plus 2 is 4. 4 squared is 16. 16 minus 2 is 7. So this one scoots over. Yeah, we're over to this guy over here. So we're kind of able to use each of those graphs to kind of do the other one. Okay, let's go ahead and, whoa, zoom that back out a little bit. Go back to my 150. There we go. Okay, so how do these functions compare to each other? Well, they are the same dilation, right? They're all x squareds. There's no multiplication in there. Just translated. This one we just scooted down. This one we just scooted over. All right, how do g of x and h of x compare to f of x? So this is how does the bottom two compare to the first one? Well, just kind of how we did that. G of x is translated down 2, or not down 2, down 9. And then, and h of x is translated down 9 and left 2. Right? So they're all just translations. We went down 9 over 2, down 9 over 2. Look back at the functions above and identify the x-intercepts of g of x. So the x-intercepts of g of x were 3 and negative 3. So 3 comma 0 and negative 3 comma 0. What are the coordinates of the points corresponding to the x-intercepts of g and x in each of the other functions? How do they compare to one another? So basically, how do they compare to x squared, where they're off by 3? How do they compare to h of x? They are 2 bigger, looks like. So h of x, x-intercepts are, so they're at 5 and -1. So, and 1, 1 comma 0, which are 2 less than g of x intercepts. Right? So they are just g of x is less 2, which would make sense because we scooted left 2. All right, next one. Graph each of these functions. All right, again, I'm going to zoom in so I can see these a little bit better. See if I can still get my functions in here. All right, so first of all is the x squared. So let's go ahead and do that one in blue. Like we had 0, 0, 1, 1, 2, 4, 2, 4, 3, 9. Okay, so let's see what we're going to do this time with them. All right, so x squared minus 4. So I'm taking my x squared and I'm dropping it down 4. So 1 minus 4 is 3. 1 minus 4 is 3. 4 minus 4 is 0. Right? 4 squared minus 4. Yep, 2 squared. And then 9 minus 4 is 5. And 16 minus 4, we don't have that one up here, so we're not able to do 4s at this point. Did I go over enough? That seems a little off. Scoot him a little more accurate there. Here we go. All right. Did I do 3? 9 squared. Oh, that one's off. That's why that's off. That should be the 3. We didn't do the 4. There we go. 3 squared is 5. There. That looks a little better. See, it seems really wide. Okay, and the last one, -1. So now we move it over +1. So instead of 0, -4, we're going to have 1, -4. And instead of 1, 3, we're going to have 2, 3. And instead of those intercepts, we're going to scoot them over 1. 3 is going to be up here on this one, because we know if we are scooting our graph to the right one, all of them are going to go right one. All right, so let's go back to our normal size. Okay, how do these functions compare to each other? So again, they are just translations of each other. Right, we took the blue one, we scooted it down to get the purple one, we scooted it right to get the green one. How do g of x and h of x compare to f of x? And same idea. G of x is translated down 4 this time, and h of x is translated down 4 and right 1 from f of x. Okay, so let's identify the x-intercepts of g of x. So that's the purple one. 2 and -2. So they are 2, 0 and -2, 0. And what are these coordinates? What are the coordinates of the points corresponding in the other functions? So in our green one, because it's 0, 0 and f of x, but our green one, our two coordinates are so h of x, x-intercepts are, we say -2, nope, -1 and 4. -1, 0, and -4, 0, which are 1, Oh, wait, 3. That one's 3. -1 and 3. What I was looking at there. Which are 1 more higher than g of x. X-intercepts, right? Which makes sense because we moved it over right 1 to do that. So how can transformations that occur to the function f of x equals x squared be used to determine where the x-intercepts of the function's image will be? So if you remember from our notes on this one, from the vertex form, f of x equals, how this looks, x minus h second power plus k. So from this form, the x-intercepts are, we got here, let's see, we had, when we rearrange this, we add 4 to the other side, we take the square root, and then we have to add whatever this is. So we are basically taking h inside and then plus or minus, and then we have the square root of k. So let me get the equation thing on here so we can write this a little bit better here. So we have h, let me find my symbols here. Here's my plus or minus, and then I need a square root of k. Oh, okay. Well, that's what it looks like right in here. Because we add this to the outside, so that's my k. I'm going to go ahead and show you the work on this so you can see how we're getting this, just to make sure. So when we do that, keep in mind I'm taking, we're not even really worrying about the a at this point, but I'm looking for when it's 0, right? And let's ignore the a for right now because we didn't have any sort of a's. We had x plus x minus h squared plus k. So we subtract k from both sides, minus k, and then we have to take, oh, I forgot the negative in there. Yeah, good thing I'm showing the math. K equals x minus h squared. So then I have to take the square root of this to cancel those out. And then I'm going to add h to the other side. So I end up with h plus or minus the square root of negative k over here. So let me go back and tweak these because I forgot the negative of negative k. And let me go back and tweak this guy. To put a negative in there. Okay. That's why we always double check our work. So that's kind of the math that goes along with it. So that's the idea of how we're getting it. All right, so use the given functions to find the missing values. So if I'm going through this process, think about what we just used here. Actually, I'm going to move that guy down. So we've got him. Move for me? Nope, doesn't want to move. Okay, we'll see if we can just keep in the screen. So f of 0, if I throw in a 0 here, 0 squared is 0, plus 4 times 0 is 0. So 0 minus 12 is negative 12. F of 2. Okay, so I'm going 2 squared plus 4 times 2 minus 12. So that's 4 plus 8 minus 12. Well, 4 plus 8 is 12, minus 12 is 0. Okay, so f of x equals 0. So now I'm going to look back up here with this equation and see what I've got. So x squared plus 4x plus, so divide by 2 equals 2. 2 squared is 4. So 4 to negative 12 would be x minus plus 2 squared. And if I'm going from 4 to negative 12, that's a negative 16, right? Okay, so now let's go back to what we had up here. And so we want it to equal 0. So if it equals 0, then we take our h, which is 2, plus or minus is kind of what we were getting at, a negative 16. So the square root of a negative 16 is a positive. So 2 plus 4 equals 6. Here we go. 6. And 2, is it a positive or negative h? That's just h. Okay. Making sure on this one. 2 minus 4 is a negative 2. So 6 and negative 2. There we go. That one goes out a little clear. Okay, so now if we make it equal to 20, then we're going to have 20 equals x plus 2 squared. Wait a minute. H is a negative 2. Negative 2 plus 4 is 2. Get stuck with those negatives. Negative 2 plus 4 is 2. Negative 2 minus 4 is negative 6. There we go. All right. H is negative 2. H. All right. Now, minus 16. So now what I have to do is I have to get this to be a 0. So I'm going to do a minus 20 on both sides. So now I have a 0 equals x plus 2 squared minus 36. So now we're going to do it with these numbers. So now I'm going to take my negative 2, my h is negative 2, plus or minus the square root of a negative 36, which is a positive 36. So I have negative 2 plus 6, negative 2 minus 6. So negative 2 plus 6 is 4, negative 2 minus 6 is negative 8. So these happen to work out nicely. 4, negative 8. We're not going to worry about the quadratic formula quite yet. All right, on this guy, we have g of x equals 0, or g of 0. So 0 minus 5 is negative 5 squared is 25. 25 plus 2 is 27. When you put a 5 in there, 5 minus 5 is 0. 0 squared plus 2 is 2. Okay, so now we've got it equaling 0. So let's go ahead and erase these, get these out of the way, so I don't have it from the next one. All right, so I want to have a 0 in here. That's already in vertex form. So I'm going to take h, which is 5, plus or minus the square root of k would be it'd be a negative 2. And actually, even though I'm going to rewrite that in the spot here, because I can't simplify that, square root of negative 2, because I have a negative inside my square root, this is not a real intercept. So part of the problem is it will never equal 0, because if you think about this, my vertex is at 5, 2, and it's opening upwards, which means it's not going to hit the x-axis. So there technically isn't an x-intercept. This is how we know, because I'm taking the square root of a negative. All right, so now I'm going to take the x minus 5 squared plus 2, and it's supposed to equal 16. Well, I need it to equal 0. So if I subtract 16 from both sides, 0 equals x minus 5 squared minus 14. Now I can fill in h is 5 plus or minus the square root of a negative 14, which means positive 14, which I don't have a square root for that, and so I'm done. All right. Thanks for watching on this one. We'll see you next time. Oh, wait. Just kidding. There's more. There's more. All right. So let's try this one. 4 more. Let's go ahead and do 12 into vertex form. So we have x minus 6x plus, so divided by 3, divided by 2 is 3, 3 squared is 9. So this is a perfect square. So x minus 3 squared. So 0 is going to be 0, 0, 9. Negative 3. Negative 3 minus 3 is negative 6 squared is 36. Because it's negative. Oh, no. Let's plug it in this one. 9 minus negative 9 is a positive 9, right? Minus 18. It's a positive. Yep, we're okay. So negative 3 times minus 3 is negative 6. Negative 6 squared is 36. All right, if we equal 0, we are doing the k, which is 0, plus or minus the square root of, what is my, no, h. I always have to get these backwards. H is on the outside, so 3 plus or minus the square root of 0. Well, that's nothing, so it must be a vertex at 0, 3, which makes sense. Now I'm going to make it equal to 16. So that means I need x minus 3 squared equals 16, which means I have to subtract 16 to get it to equal to 0, which means I need to do my h3 plus or minus the square root of a negative k, 16. So here I have 3 plus 4, which is 7, and 3 minus 4, which is negative 1. Okay, this one over here. G of 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. 5. 5 minus 2 is 3. 3 squared is 9. 9 minus 3 is 6. Okay, let's throw in the 0. So I need h plus or minus, my h is 2, plus or minus the square root of negative k. So in this case, it's a 3. So I can't simplify that, so that's it. All right, when g of x equals negative 3, let's go ahead and rewrite this here. So if it equals negative 3, that means I'm going to add 3 to the side, right? So then, right, negative 3 equals that. I need to add it to get rid of it. So then I'm going to have h2 plus or minus the square root of a negative 3, which means there should be no x-intercept. It shouldn't cross at that, right? Let's see. Oh, what am I doing? I had a negative 3. Like, that doesn't seem right. Minus 3. Negative 3. If I add 3, these cancel. 0 equals x minus 2 squared, which means, there we go, h plus or minus the square root of 0. So it's just, so it should cross because we just had a 0. equals 2. All right, next one. X plus 5. 0 plus 5 is 0, or sorry, 5. 5 squared is 25. Negative 2 plus 5 is 3. 3 squared is 9. Now throw in the 0. So h is 5 plus or minus the square root of k, which, h is negative 5. Take that back, it's a plus there. All right, so if that equals 9. X plus 5 squared. If it's equals 9, then I need to subtract 9 to get that to a 0. So my new h is negative 5 plus or minus the square root of the negative k, which is 9. So negative 5 plus 3, negative 5 minus 3. So negative 5 plus 3 is negative 2, minus 3 is negative 8. Those are my intercepts. All right, and 15. 0. 0 plus 1 is 0. It's 1. 1 squared is 1. Negative 1 plus 8 is 7. 2. 2 plus 1 is 3. 3 squared is 9. Negative 9 plus 8 is negative 1. Okay, now here we have x equaling 0. So my h is a negative 1, and my k plus or minus the square root of a negative 8. We do have this negative over here. So we are going to have just 8. So that negative is taken into account because it's flipped over. And so, positive 8, okay. And so now we can actually simplify this to negative 1 plus or minus 2 square root of 2, right? Because 8 can be broken up to the square root of 4 and the square root of 2. And so we leave it just like that. Okay. When it equals 4, then I'm going to 4 equals negative x plus 1 squared plus 8. Need to subtract 4. So then I have 0 equaling, so when we divide out of this, that doesn't really change a whole lot with this guy, but negative x plus 1, or sorry, x plus 1 squared plus 4. So we are going to now have the negative 1 plus or minus square root of the negative 4. And so negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. There we go. And that is it in this case. All right, thanks for joining us, and we'll see you next time.